Hello, today I'd like to talk about theories and laws and models and all that wonderful stuff. A lot of people have misconceptions about what the word theory is, at least in the scientific or academic sense. Some people say, oh, I don't believe in the theory of evolution, it's just a theory, that means it's not been proven yet. Well, some people say, oh, I don't believe in this vaccine, I'm not going to get this vaccine. Apparently they don't believe in germ theory, the reality of certain diseases. Well, there's a law of gravity, but there's also a theory of gravity, and it's a little different. You can't just say, oh, I don't believe in the theory of gravity. It's just a theory. It hasn't been proven. I'm just going to walk off this building and fly or float. Yeah, go ahead and try that. No, don't. There are fundamental misunderstandings in popular culture about the word theory. And a theory is not the same as a law. And I'm going to explain that in this video. So stay tuned. In 1687, Sir Isaac Newton published his famous Law of Gravity. And it was, of course, quite provable. But still, some people didn't quite believe it. Why? They said, okay, Mr. Newton, you have this law of gravity, but what causes this gravity stuff? And you know what? He didn't have an explanation. He had no idea what caused gravity. No one did. But it was accepted as a law. So what some people were looking for was an explanation. What is gravity? What causes it? That's the theory. So in colloquial English, or everyday conversational English, or common parlance, the kind of common everyday way of speaking, the word theory has a different meaning. So in kind of general English, I might say, oh, my theory is that, she's going to run for president in 4 years. And that's not theory in the scientific sense. That's theory in the colloquial sense of really more like a guess, a conjecture. Maybe the closest thing in science would be a hypothesis, perhaps. It's just my guess, my belief that that person is going to run for president. It's not a testable scientific theory. In science and academic disciplines, other academic disciplines, the word theory has a different meaning. It is not the case that a theory gets proven true and becomes a law. And that's why we have a law of gravity and we have a theory of gravity, and those are different things. And yeah, the law of gravity is part of the theory of gravity, but they're different. A theory is something much bigger. A theory is an explanation for why something is. Now let's compare theory and law. A law is a general statement or an absolute statement that's generally true or always true, at least for what it's intended to describe. A theory is an explanation why something is the way it is. A law doesn't tell you why necessarily, it just tells you what is. A theory is an attempt to provide an explanation, and so law is something pretty simple. It's a simple equation or formula or a statement. I'll give examples and some more examples in a minute. A law is something very short and simple. A theory is much bigger. It's more of a framework. It's a conceptual framework that provides an explanation. That is, it's a set of ideas or statements or propositions which together form a coherent explanation of why something is. More examples in a minute. A law is generally true, and a theory can be true. It can be proven. So some theories are proven true. Some theories maybe have been disproven and discarded. There are some theories that you may hear about that we're not sure about. We haven't proven them or disproven them yet. Let's go through some examples. E equals mc squared. You learned that in middle school. That is a law. Now, it is part of Einstein's special theory of relativity. The special theory of relativity is a bigger theory that explains the relationship between energy and mass, and it consists of this law and some other laws and some other propositions or statements that make up a whole theory that explain the relationship between mass and energy. And of course, this has been proven true time and time again. The special theory of relativity has been proven true. The law of gravity was from Mr. Newton. And who came up with the first theory or explanation? Well, it was Mr. Einstein again. A few years after he published his special theory of relativity, he came out with a general theory of relativity, which explains the relationship between time and space and including gravity and lots of other things. It's a much more general theory that explains a lot of stuff. And included in that is an explanation of gravity, at least on a big scale. So our gravitational theory comes from Einstein and is part of his general theory of relativity. The general theory of relativity has been proven true time and time again. And if you think it's not relevant to your daily life, well, the special theory of relativity gives us nuclear power. The general theory of relativity gives you something that you probably use regularly. Use GPS or navigation systems. Without the general theory of relativity and Einstein's gravitational theory, that wouldn't be possible, because your GPS or navigation device, down here, has to communicate with at least one satellite up in space, maybe two, and it has to triangulate, the satellite position, your position, and the destination where you're going. Well, the thing is, satellites in space experience time differently, because Einstein's general theory also, explained the relationship between time and space and gravity and other stuff. Those satellites experience time differently. There are two different things that affect them: the low gravity and their speed, because they're in orbit above a certain location, so they're going really fast. They experience time differently, and it's because of Einstein's equations that we can correct for the time differences, so you can get to your destination. So that's a theory. The general theory consists of a number of different equations and other statements that form the general theory of relativity. There are many other laws in science. Science is just full of laws: physics, chemistry, etc. Economics, there's the law of supply and demand, and it states that there is a relationship between supply and demand of a product and its price. Now, a law is generally true for its intended purpose. So the law of supply and demand works for normal situations. Yeah, there are other factors that can influence things, of course, but it generally holds in normal situations. It doesn't apply to extreme cases like war or disasters and such, but in normal situations it applies. Just like Newton's law of gravity applies to normal situations, it doesn't apply to black holes or if you're moving near the speed of light. That's where you use Einstein's equations. But a law works for its intended domain, what it's attempting to describe. So you have the law of supply and demand. Now, it doesn't give you a full explanation for why that is. And in economics, there are other theories that provide more explanations about why things are. One famous theory in economics is game theory, which it's not just about supply and demand, it's about consumer choice and how people make choices. And it's a pretty sophisticated theory. So there are game theory or other theories in economics that you would then use to explain things. Evolution. There's the fact of evolution, which has been proven true, especially by genetic evidence. And then there's a theory of explanation that explains evolution. And the theory of evolution was first proposed by Darwin to explain the variety and diversity and similarities and differences in life forms among various species in the earth. And so as a theory, it consists of a set of propositions. There is a statement about a variety and diversity of life forms and similarities and resemblances. There's another proposition or statement about one of the means of evolution, which is mutation. Now, mutation is often misunderstood in biology. It's not talking about, say, a chicken that's born with, 2 heads and 3 wings, like a bad genetics experiment. No, mutation in biology just means a change. A change happens. I have blue eyes. That's a mutation. It arose in Europe 10,000 years ago. People thought it was sexy, and so it caught on. And here I am today. That's a mutation. I'm a mutant, I guess. It just means a genetic change. It can be good, bad, neutral. Another part of the theory of evolution is natural selection. It's one of the means by which evolution happens. Darwin never said survival of the fittest. That's not a proper term in biology. That term was coined not by a biologist, but by a sociologist who had a very crazy theory that had nothing to do with biology. Survival of the fittest is not part of the theory of evolution. After genetics was discovered, that was added to the theory of evolution, and in recent decades, a couple of other components have been added regarding the mechanisms or how evolution happens. So evolution explains how life develops. It is not intended to explain how life first began. That would be a different theory, something called abiogenesis, which is something that scientists are working on. We don't have a complete theory of that yet. But evolution does not explain how life first began, but it explains what happens when you do have life, how life forms change and evolve. There's germ theory, which explains how communicable diseases, that is, diseases that can be transmitted from person to person, spread through viruses and bacteria. And of course, it's been proven. You can't just say, I don't believe it, I'm not going to get this vaccine, I'll just, expose myself and I'm going to be fine. Yeah. There were some people in the US who kind of had that attitude, and some of them kind of died from COVID. So, not good. Big Bang Theory, of course, it explains the development of the universe from its beginnings. It doesn't explain what caused the Big Bang, but explains what happened from that point. Quantum field theory, very successful theory about what happens in physics at the very tiny level below the atoms. Those are theories that have been proven true. There are some theories you might hear about that haven't been proven yet. One popular theory in science is string theory, which goes beyond quantum field theory and relativity to explain bigger stuff, kind of a theory of everything. We can't prove it. Scientists really don't know how to test it. It's unproven. It might be true, it might not be true. We have really no good way of testing it. Maybe in 50 years we'll know. Who knows? String theory is kind of interesting, but controversial. Now, you've heard of theories, but then you may hear of models. And those are a little different. So a theory is an attempt to give a complete explanation for something. A model isn't trying to necessarily explain something. Models are often kind of descriptions, kind of a simplified description, either in words or in pictures, or often both. There are a lot of models in psychology and other social sciences. One famous model in linguistics is Kachu's three-circle model. It is a model concerning the status of English in different countries. It is not attempting to explain why, but it is a very useful model that people in sociolinguistics, or the study of language as a social phenomenon, social study of language, use to then help describe and analyze the role and status of English and related issues in different countries. So according to this model, there are what's called the inner circle countries, where English is a fully native language. It's people's everyday language, as well as the main language of like education and business and government. Then there is the so-called outer circle, and that's where English is not people's home language, but it is the main language for education and or business and or government. So it's not a language that most people really use at home, but it's important and fundamental to the country's education, government, and business. Examples would be India, Singapore, Malaysia, Nigeria, and as well as entities like Hong Kong and such. Then there is the so-called expanding circle. That would be most countries of the world where English is just a foreign language. It's not spoken in the home, and it's not the primary language for government, business, or education. It is a foreign language, and it's mainly something used at school or for interacting with foreigners in certain contexts. And that's been a successful model in linguistics. Again, there are lots of models that are used in various social science fields. In statistics, if you have a statistics equation, you talk about statistical models, like kind of an equation that represents a relationship between your outcome and various factors that explain it or influence it or correlate with it or maybe lead to or cause an outcome. Statistical models are kind of models that you create in the process of your statistical analysis. Some models are kind of descriptive and provide maybe a partial explanation. So there is a standard model of physics, which provides some explanation for different forces in subatomic particles, but not all of them. There are some things that it can't explain. It's a partial explanation, but it's been fairly successful. Then you hear the term framework, which is kind of similar. It's maybe less coherent than a model as a description. It may be often, or sometimes people use framework and model interchangeably. They can be similar, maybe the same, but especially in like business, for example, you hear the term framework, and it's maybe kind of like a model. It's a set of principles or guidelines or criteria that you might use for describing a business case or business situation or analyzing a business case, or as guidelines for setting up a company, or kind of some criteria for critiquing and analyzing, say business case studies for critiquing companies and such. Then there is a hypothesis, or plural hypotheses. That is a specific prediction, and it's often based on a theory or model. Not always, but often. So based on this theory that we work in, what would we predict when we look at this new situation? So based on this linguistic theory, if you look at the verb forms in this language and what they do, what would we expect if we apply this theory to analyzing those verb forms in this new language that we found? Something like that. Or if we do a study of penguin bones in different species in different areas over time, what would we expect according to various theories? That's a hypothesis, something you test and prove or disprove in a scientific paper. Now, by the way, since I'm from a linguistics background, and some of you watching this might be language majors or linguistics majors, let's talk a little bit about linguistics theories, just a brief overview. Because different linguists have different theories. Sometimes they have trouble understanding each other's perspectives and where they're coming from. They're just coming from different perspectives, different theories that have kind of slightly different questions or purposes or goals. Let's take syntax. Now, syntax is kind of like an attempt to come up with a theory of grammar, why grammar is the way it is and how it works in a language and how it works in different languages, human languages in general. The most common one that you might have heard of is generative syntax. And it's actually not one theory, but a set of theories that have kind of changed over time. These are mainly from Noam Chomsky, the famous linguist. And actually he's had different versions of his theories of syntax that have changed over time. The specific names of theories have changed over time as he's kind of moved from one theory to another theory, but within the general kind of set of principles. Generative syntax, generative theory kind of postulates that there is a grammar ability or faculty in the human mind, in the human brain, that's innate. We're born with it. It's in all humans, and it's kind of universal, that humans have this universal set of principles in the mind, and there are different views on how that works and such. But all languages have kind of the same linguistic principles or tools they can draw from, but implement in different ways to come up with really different grammars, and so that the grammars of different languages look very different on the surface, but deep down they have the same kind of tools or principles. And so the theory involves a lot of abstract structure. There's a lot of abstract structure in, say, human sentences and human grammar, in the grammar of a particular language, that you're not aware of when you're using a language, because it's abstract, it's subconscious, but it's there, and these abstract structures can explain the grammar of different languages. So all languages draw from the same abstract set of principles or tools and structures to come up with really different looking grammars. And another thing involved is something called transformations or derivations. Don't worry about that, but it's basically a way of explaining how different sentences in a language are kind of related. different forms or varieties of a sentence are related, or where the structure comes from, or how the structure changes and such in the grammar. And that's kind of very abstract. And then there are some other people within the generative framework who reject some of those things, especially the idea of transformations, and they have alternative generative theories like optimality theory, which you can study on your own. Another framework or theoretical approach is cognitive grammar, and this is one I've also worked in and been influenced by. The basic idea is the grammar of human language and languages is based on kind of psychological categories, how humans perceive the world and how we categorize things, and it leads to kind of regular principles in human grammar that are ultimately based on psychological principles and categories. It's very interesting, and one that I kind of like too. And there's functional grammar, which is one I haven't really gotten into very much, but it's a theory of grammar based on communicative functions and principles, what people are trying to do with different types of grammatical structures and what they convey, and is particularly popular for those in the world of language teaching and training teachers. It is kind of maybe more practical for language teachers. All of these theories have their strengths and weaknesses. There's some things I like and dislike about each of these, and there are many more, especially when it comes to other questions in language. There are many other theories. For example, theories about phonology or sound structure of language, theories about how words and grammatical endings get put together, a lot of theories about pragmatics or about meaning and how language is used in actual context, theories of semantics or the meanings of words themselves, theories in sociolinguistics, or the social study of language, the study of social aspects of language, and so on and so on. There are lots and lots and lots of theories out there in linguistics. There are theories in most fields, most academic fields, psychology, economics, science, math, etc., have their theories. So, what does this mean? Applications. First of all, if you're doing academic writing and taking especially an advanced course, maybe an advanced college course, like a third or fourth year course that's kind of more advanced, or especially if you're studying in a master's or PhD program and maybe you're really getting deep into the stuff for the first time, you might be confused because you don't really have a good grasp of the theories that are important to the field, the theories you need to know. For starters, you can maybe ask ChatGPT, hey, tell me about the theories in this very specific research field. Don't just say, hey, tell me about theories in linguistics, because there are too many. Tell me about, this theory of syntax. And then from there, go online and do more searching and reading about the particular theories that you need to know in order to understand your field if you are wanting to do more advanced studies in the field, and you need a really good solid command of the theories. Because sadly, even in graduate school, sometimes professors just assume their theories and assume you know something about them, but you don't. And this is something that maybe is I think a problem in education, especially in graduate school. Sometimes the professors just don't explain the theories to you. They just don't realize they've worked within the theory for so long, and they kind of don't realize that the students really don't know anything about the theory that they need to know. And so this can be confusing and frustrating for graduate students in some fields, especially like linguistics, where there are just so many theories. So get to know your theories, because that shapes how people write. It shapes the knowledge you need in order to understand academic papers that you're reading, and then how to write academic papers you need to write for your classes. Maybe if you have to talk to your professor after class, outside of class, ask, hey, could you explain this theory more specifically? Can you break it down? Or talk to maybe a senior student, who's older, more experienced than you, and say, hey, can you explain this theory to me? Hopefully they can. Um, Sometimes professors don't know how to explain theories very well because they've just been, just like fish don't know they're in water, and sometimes professors don't really have a good awareness of what it's like for a beginner to deal with the theory, and sometimes they don't even know how to explain it very well. Some professors just don't explain things very well, and if you can't rely on your professors, find older students. Maybe get really good at asking ChatGPT very specific questions about a particular theory, and okay, what are the assumptions of this theory? How would this theory explain, such and such things, phenomena, or whatever? Maybe those are things you might have to do, as well as from there then going on to looking up more specific information online to get a basic foundation in the theories that you need to know to understand the stuff for your classes, especially if you are in graduate school. Okay, I hope this helps. Now I'm going to kind of continue this line of thought in the next lecture, and it's going to get a little more philosophical. We're getting into the philosophy behind theories in academic fields and academic studies. Hopefully your head won't explode, but hopefully it'll be kind of useful too, especially if you are interested in more academic study in your field. So until the next lecture, good luck, take care, I'll see you later. Goodbye.